Hi, this is Mega Geek and I'm Dan. This is hopefully going to be the first video in a series of videos, Summer of CNC 2019. The thinking at the moment is that there will be a few videos over the next couple of months in which I focus on my wonderful trusty Ooznest OX CNC. And part of the inspiration for this is that a few weeks ago at Maker Central, I went to the Ooznest booth and had a nice long chat with Ryan. Looking and admiring their new machines. They have the Work B CNC machines now, and I was admiring some of the design upgrades, some of the tweaks that they've made to how things go. One of the things that he was telling me about was the electronics on the new machines. They use the Duet board, which is notionally designed, I guess, initially for 3D printers, but it's essentially the same thing. It can control a bunch of motors, heaters, etc. It has a nice interface. And so that's what they're using on the new machines, and he said that it is an upgrade from what I have. When I bought the machine a few years ago, I bought it with an xPro USB board, and that's been good. It runs durable under the covers. It served me well. However, Ryan tells me that the Duet is an improvement, and he was kind enough to send me a Duet Wi-Fi. So the plan is to upgrade the OX, but first, in order to really see the difference, I want to design a few tests of the current setup to kind of show what it's capable of, but then when I do the upgrade, which will be its own video, I can then hopefully repeat all of those tests with the Duet, and we'll have kind of a point of comparison to see how things differ. We'll see how that pans out. It may be difficult. I don't know how far or how much to spend tuning and tweaking the settings on the existing electronics, but broadly I figure I'll go with what I've got, which is what I originally tuned, and then we'll see how the Duet compares. So that's the plan. Right now, in terms of tune-up, I've already gone round the carriage and just checked all of these wheels. There were a couple of these that had gotten loose over time, so I snugged them up with the little offset nuts that these are set up with. Just going to do the same thing on the Y carriage, and I can already feel one of these back here is just a little bit loose. So I'm just going to whip around, tighten these up, make sure everything is snugged in properly. Then the first test we're going to do is pretty much the first test I think I did when I built the machine in the first place, which is the Shapeoko calibration test. I mean, it's only called the Shapeoko because the person that created it was doing it on a Shapeoko, but it's just a kind of a bit of a mean test. A lot of people do it with a pen. I'm going to do it with a fine V-bit into hardboard, but we're not going to be really generating much cutting load. This is very much a test of precision, repeatability, squareness of your squares, roundness of your rounds, that sort of thing. So, wheels tightened. We'll get ourselves lined up for the calibration test, and let's get on with it. The control system for my CNC at the moment is basically a Raspberry Pi, which is screwed to the back of this pillar, which is connected to the xPro, and it runs BCNC. There are a bunch of different options. BCNC has been working really well for me. Essentially, this is something that connects over serial to the xPro USB and sends it the G-code commands live, I believe, with the Duet. It's an all-in-one deal, so you give it the whole file and it controls everything, but we'll get to that later. I've loaded up the Shapeoko. Let's just fit that to screen. I've loaded up the calibration, so you can hopefully, I don't know how well the camera will pick up the display, but it's a series of squares and diagonals and circles inside of circles. That's the plan. So we're going to just home the machine, figure out where our material is, set our 0. I'm pretty sure. Now this is the file. You can get it off of the one of the forums. I'll put a link in the description. It's already G-code, which is unusual for me. I normally start from a design and create my own G-code. I guess the advantage of this is that it will be it's a standard test, I guess. It won't be influenced by the way I would set things up, but it does mean I need to know, do they put 0 at the top of the material or the bottom material, what's going on. So we'll just pop across to the editor, and have a look in here. So it looks like we're setting 1000 RPM on the spindle. That's a little bit slow, so I might just bump that up, because I guess again this test is normally set up to be like a pen drawn thing. I think I'll bump that to maybe even 10,000 RPM just for this sharp point into hardboard. And having a look, Z2, Z0, Z2. So I think that looks like, yeah, I think we're treating Z0 as like actually what we're marking on. Z2 is our move height. So I should be able to just move us across, set the point kind of just into the material at the point that I want to engrave it, and then head off. So let's come over to control and home the machine, and whilst that travels to position, we will then from that known point move ourselves across, and let's get it going. Well, this is embarrassing. Well, a little bit embarrassing. This was a terrible choice of material for this test. It's been a while since I've done this. Bad choice of material, and I have not leveled the bed on my CNC for a little while. The last thing I was doing was the doors project, and I actually took my main bed off for that because it was such a deep material. So whilst I put the bed back on, I've not really leveled it, and looking at it now I can see there is a bow in that piece of material. So where I carefully got myself just into the wood over here, it just dragged all the way across. There's a whole bunch of extra diagonals in here where it wasn't even clearing, so it cut a lot deeper than I was intending. But it's pretty good. I mean, there's a whole bunch, the whole point of this calibration sort of pattern is that there's a whole bunch of points where it's like this should be an inch, this should be 6 inches, and I would say everything is within like 0.01 of an inch of what it says it should be. Everything is square. The only thing slightly off maybe is the circles are a little bit squidged. I've always had this problem with circles, and I'm sort of hoping that this might be a key place where the Duet sort of shines and makes a difference. I don't know whether it's mechanical or not. If it's not mechanical and it is just an interpolation of those curves, then maybe that will help. But what I'm probably going to do is rerun the test with a better material, get myself properly flat on the bed, because I do want this to be a good comparison and I would like it to do a better job. So what I'm probably going to use is a chunk of oak flooring, which I think will make a nicer material. It won't flake away like the top layers as the plywood has done. But I am going to try running it faster. So the file as it comes runs at like 500 millimeters a minute on the feed. I'm going to jack that up right to 1000, see how the machine copes, because I kind of want to push the envelope a little bit in terms of speed and acceleration, because again, this will only really show a difference if we're kind of pushing the boundaries of what we can do. So let's do that. Well, that's the calibration test done. I leveled the bed off. I used something that was pretty flat. I didn't get it completely flat. I could have run a pre-pass before I did the pattern to get this surface as flat as possible, but I think for what I'm trying to prove here it wasn't necessary. I ran the calibration test twice, one at 1/8 microstepping, which is how I've had the machine set up for most of its time, and one at 16th microstepping, because I was curious to remind myself, I guess, if that made any real difference. Seemed to go well enough both times. The second pass was a little deeper, so you lose some of the finer detail. I will say that With the 16th microstepping, it does seem like maybe we got slightly more variance on the diagonals than I was expecting, and though there's definitely a fault, some backlashes present on the sort of interlocking on the squares inside squares. You can kind of see the little tail on the edge of some of those where it started and stopped in a slightly different place. A couple of the diagonals, like, they look pretty tight, but they're ever so slightly shifted, and the circles in both cases, again, they're pretty good. Put a washer over the top of them, like, they look very close to circular, but they're just ever so slightly elongated on the diagonal, and I think that is pretty much the same between the two. I ran both of these at 1500 millimeters per minute feed rate and 10,000 RPM on the spindle. I didn't change any of my acceleration settings. I'm gonna leave those as is. I'll see how the Duet sort of performs with its defaults and how much tuning that requires. So, calibration basic done. Next step, I think, is I'm going to do a job which I've done before on the machine, which is to create it's a cribbage board design, but it has a bunch of operations, facing, pocketing, 3D profiles, etc. Going to time all the operations. We'll do them in this video against the xPro. Then in the next video, I'll actually do the upgrade, wiring and such like. And then in a third video, hopefully, I'll do the same set of operations with the new electronics, and with any luck we'll be able to draw some conclusions and do some comparisons. So that is the plan. Let's do it. Well, let's talk about failure, shall we? Well, not too bad, but that did not go as smoothly as it could have done. A couple of things were my fault, a couple of things maybe are to do with the xPro USB and the voltage management of the motors, but let's get into what we did. So, first failure, this was me just leveling off a board. I pretty much realized, well, there was a couple of things that messed up here. One was I hadn't actually adjusted the tramming on the router mount for quite a while, and certainly not since I think I added the new plastic, which isn't a problem for a lot of things, but once you start to do flattening, you can see kind of these ridge lines that come in because it's going at a camber. That also means you get a very uneven force attached. I messed up a couple of times with the height. So the last thing I did on the OX was CNC the ripple doors, which were quite thick, so I took the bed off and clamped those doors directly to the frame of the machine. When I put the bed back on, I managed to accidentally line up some of my screw holes on top of one of those cross braces. So I got myself a nice flat bed, then clamped this down, and one of the clamps I used pushed a screw against that bottom frame and just pressed the whole center of the bed up into a bow, which I totally didn't notice from my point of view. But that basically meant that I got myself nice and flat and level at zero at this side of the board, and by the time I got to this side of the board, it was a huge deep cut that just burned in and couldn't cope. That was really frustrating. I eventually figured out what the hell was going on. Felt a little bit stupid, but it did make me realize I need to do tramming, and so I dug out the big boy. This is big half-inch bit, half-inch shank fly cutter type thing. I've not actually used this before because I didn't get a half-inch collet, but I bought one recently just so that I could start using this. But also because it's so wide, it really helps with dialing in tramming, because you can kind of really accentuate any difference there. And so I fiddled around a little bit off camera, got it dialed in, shimmed it in a little bit. So basically I put these little pieces of cardboard down the back to just kind of tip the top a little bit. It's not perfect, but it is a lot better. And it was good to get that sorted this side of the test. So that being said, this is the result of a number of machining operations, and it's not perfect. Now I've made one of these before with this setup, with this machine. It came out great. The things that didn't go right here were a little bit of my fault, but there are also some things that didn't go right the first time, but I fixed through sanding and fiddling. So the operations that you just saw were a facing operation to flatten the stock, then a 2D contour operation to take away the exterior shape, then a 3D carving operation that cut these ring slopes in. Oh, obviously the drilling operation that drilled a couple hundred holes, and then a 2D pocket operation with a 3mm bit to pocket in the logos here, and then a rest machining with a 1.5mm bit. Now, the rest machining with a 1.5mm bit is where things kind of went wrong, and part of that is that I did all of the rest of the operations last week, then I came back this week. I had not been resetting to home between each operation, and this is where I think we do get into maybe a combination of user error, maybe a combination of the electronics being a problem. I think that we shifted slightly, certainly perhaps within the 3D operation. There are a few spots here where it's quite jagged, which you'll see from the close-up, with the whole machine kind of shaking around a path. Now, I'm not sure the electronics will fix that necessarily, but I think maybe I stalled it slightly, shifted, not more than a mil or so off, but if I'd been resetting home between all those job operations, it kind of wouldn't have mattered as much, because I think I would have stayed somewhat consistent. But where I reset to home today, and then with the 1.5mm bit it came in, it's just slightly off in all of its locations, both in depth and in XY. Not hugely off. Now, I saw it was going to be off sort of right from the first kind of cut, and I did think about just stopping it, maybe skipping that step. I could have fixed the damage of that, but I thought, you know what? It's part of the process. Like, part of this video is really just about, well, how long did it take to do that operation? How smooth is it? Obviously, it would be nice if it had done it in the right location exactly. But I think for this purpose, it was fine to let it just be slightly off, and it gave me something to talk about. Okay, with test 1 done, that's it for the xPro. Next time, we'll do the wiring for the new Duet Wi-Fi. For now, though, thanks for watching. See you next time.